action. All right. Second. So I got the music. That load up music, you know what I'm saying? Somebody? Hey. Yeah. I did that, by the way, you know what I'm saying? Slow step down. Do instrumentals. This song, whatever, you know what I'm saying, you need necessary. Whatever. You may be interested in. For some version 1 and 2s, I do that too. Get it in this here though. Hey. I don't learn no fast internet, man. So forgive me. Seems like it works slower on Facebook. Let me go all the way through. Back. Let's go all the way. Oh man, I'm happy. Again, full screen. Right. Virulence versus Fitness and Benefit versus Risk by Chavis Tep-Hesson. I will be Craig. Research questions. What is the significance of virulence? What relevance, if any, does viral fitness have in relation to virulence? How are public health benefit and risk metric formulated? Is it in our benefit to vaccinate according to available data? Hypothesis. Terms virulence and viral fitness are essential in understanding a common misunderstanding influenced by the media due to lack of command in subject matter and oversimplifying language in regards to transmissibility, variants concern, and assessing exactly how deadly SARS-CoV-2 and its variants are. Knowledge of the facts of how effective new third-generation vaccines are should add weight to how much it benefits one to vaccinate during a global pandemic. Background information on the metrics of how benefit and risk are gauged should help us in drawing a rational conclusion. What is virulence? The noun virulence derives from the adjective virulent, meaning disease severity, virulent, Oxford Dictionary. The word virulent derives from the Latin word virulentus, meaning poison, wound, or full of poison. The Latin dictionary, virulentus. A pathogen's virulence is the negative impact it has on hosts. As a trait, virulence correlates with the pathogen's fitness and hence can undergo selection. Indirectly transmitted pathogens higher within host growth rates are associated with higher transmission rates and greater fitness of the pathogen. Higher growth rates are often result in higher virulence, resulting in the co-selection of virulence along with fitness. When expressed as mortality, increased virulence limits the amount of time an infected individual can transmit pathogen. This sets up the trade-off between infection duration and transmission probability, theoretically resulting in optimal level of intermediate virulence. However, the nature of such trade-offs depends on the life history strategies of both the pathogen and the host. Therefore, understanding virulence evolution pressures in different disease systems, e.g., vector-borne, environmentally transmitted, and opportunistic, is critical to forecasting the disease dynamics under changing conditions. Historically, pathogenesis research has focused on identification and characterization of virulence factors. More recently, antivirulence genes have been discovered. Mutations in these loci result in hypervirulent phenotype as measured by a lower lethal dose, a colonization advantage, reduced clearance, or decreased survival time of the host. If these genes function to reduce pathogen virulence, why have they been retained? Multiple hypotheses have been offered to explain this phenomenon. First couple times trying this, I had some issues with the loading. So what I'll try to do is let it load a little bit before I hit play. Hopefully that'll make it not slow down. Let's go.
So today we're going to talk about virulence and how we study it. And one of the ways that we do is in animals, as we've just talked about. Virulence is the ability or capacity of a virus to cause disease in a host. And usually we're talking about in animals. We don't usually talk about virulent viruses in cell culture. We're referring to a host. And we talk about virulent viruses, which cause disease, and we talk about attenuated viruses, which do not cause disease. And typically our vaccines, our infectious viral vaccines, we call attenuated because they do not cause disease. Now, that is not a very exact definition, virulent and attenuated. So we can measure virulence and put a number on it. And there are many different ways that we can measure virulence. And these are just a few of them here. To give you an example, you could infect an animal and see how long it takes for the animal to die, a very crude approximation, but it can be compared. Mean time to death, you could look for symptoms. If there are some symptoms that you can measure, fever, weight loss, for example, are common ones, some kind of cell that's produced, anything that you can measure specifically and precisely in the lab, you can use as a measure of virulence. Or you could measure the actual effect of the virus on the animal, the production of lesions in a specific organ. So poliovirus not only produces paralysis, which you can measure. You can say how many days it took for the animal to become paralyzed, how many limbs were paralyzed. You can also look at the spinal cord and brain pathologically and ask, are there lesions? You can look at it under a microscope. For HIV, for example, a common measure is the concentration of CD4 positive lymphocytes in the blood, because we know the virus replicates in them and destroys them. So the number per microliter of blood is a measure for how virulent the strain is. So
that worked out good. One more. Try to do the same with this one. Let it get a little head start on the load because your boy don't got the best internet service, even though the Wi-Fi is on. It's in the other room, so I don't know. Shit gets kind of slow. Let's see what we can do with this one.
That is done quite often. So in virology, one of the major goals of our work is to identify the determinants of virulence. We want to know the genes that are involved, both in the virus and the host. So just like the viral and host genes of the immune response combine to make pathogenesis, to make the disease occur, the virulence of a virus is determined by both viral genes and host genes. And I'm going to go through a number of examples to tell you about that and how it works. We usually identify these genes in the virus by mutation. We take a virus, we make mutations throughout its genome, and then we put the viruses in animals and we ask which mutations knock out or reduce virulence. We use a very precise assay, of course, and then we try and figure out what those genes are doing. Up until not too long ago, we couldn't make mutations in animal hosts. And so it was very difficult to understand the genes in the host that influence virulence. There were some naturally occurring variants like mouse strains, for example, that are different and have different outcomes after infection. So those were used. But now we can make mutations. We can knock out genes in mice very readily by a variety of technologies. So we are now getting a really good indication on what host genes are involved. And to make it even more exciting, in people, we can't knock out genes in people, but we can, but we're not allowed to. We can use whole genome sequencing and compare people who get very sick from a virus and people who don't get sick, because we can sequence someone's genome in a day now, right? So you can easily get sequenced and ask what genes are different. Now, this is not a trivial exercise because we have 3 billion base pairs in our genome. So just analyzing the data is quite a chore, but it's now possible, and I'll show you examples of this in a bit, of identifying mutations that correlate with susceptibility to virus infection. So here's an example of how we would identify a viral virulence gene. We take a virus that grows nicely in cell culture, makes plaques, so we can assay it, and we infect the mice with it, and the virus replicates and it causes paralysis. So this virus is neurovirulent. We then have made a mutation in this virus, which affects the replication in cell culture. It doesn't grow well. You can see there are fewer plaques. We put this virus in an animal, and of course it's attenuated. It's reduced virulence because it doesn't grow very well. So this is not an interesting result. We don't want to identify genes that affect general replication because obviously they're going to be less virulent. They can't replicate as well, and they're overcome by the immune response. What you want are viruses like those shown at the bottom here. You make a mutation that does not affect viral growth. Now, there's an error in this figure. These plaques should not be smaller. They should be the same size and the same number as the wild type virus. So this virus has a mutation in a gene that doesn't affect replication in cells. And when you inoculate this virus into animals, any animals say it doesn't replicate well and it's attenuated. Those are the genes that we're interested in because they are specifically required for growing or some aspect of pathogenesis in the animal that affects virulence.
That worked out good. All right. For viral fitness was originally defined as the capacity of a virus to produce infectious progeny in a given environment. The definition is still in wide use today, referred to more specifically as replicative fitness. This standard definition is founded in, but does not exactly match, the more general Darwinian definition of overall fitness, which is the amount of genetic material passed on to the next generation due to host immune clearance of viruses and finite host lifespan. Virus must be transmitted to a new host to survive as such. Transmission fitness is an important component of overall fitness. Ultimately, replication and transmission contribute to the prevalence of viral genetic material at a population level in the field over time. The capacity of a virus, a serotype, clade, or variant to become dominant in the field relative to other serotype, clades, or variants of the same virus has been defined as epidemiologic fitness. Fitness is a complex parameter often used by evolutionary biologists and ecologists to quantitatively describe the reproductive ability of evolutionary potential of an organism into a particular environment. Here he's going to describe this, and on the side we have, let me see if I can get this started. So we have, this is influenza virus. It walks you through the steps of how this takes place. You got influenza virus. Influenza virus becomes attached to a target epithelial cell. The cell engulfs the virus by endocytosis. The viral contents are released. Viral RNA enters the nucleus where it is replicated by the viral RNA polymerase. Viral RNA is used to make viral proteins. New viral particles are made and released into the extracellular fluid. The cell, which is not killed in the process, continues to make the virus. So here is Mr. Daniel Green. Oh, yeah, Daniel Griffin. Infectious disease expert, going in on this particular topic.
Ran across this, but this was written by a Dr. Rosenfeld and a Dr. Rackaniello. Yes, same Amy and Vincent that our listeners might know. And the article really does an excellent job of making the point that I'll be touching on today. So ultimately, a virus has a genetic sequence that changes, and these changes can be neutral, they can be favorable. They're usually unfavorable in terms of viral fitness. This is my sort of request to the audience and the media to start using the word fitness rather than transmissibility. And this viral fitness is really the same Darwinian concept that underlies the whole survival of the fittest that many of us learned about if we were allowed to be taught that in our schools. And reproduction is a chance for an organism to end up with improved fitness, and we have certainly given SARS-CoV-2 the opportunity to reproduce. And it's not surprising that we are seeing that the Delta variant, that there's evidence to suggest that it has improved fitness, that it's going to have the ability to outcompete other viruses.
Right. Benefits outweigh risks. Vaccine benefits. None of the COVID-19 vaccine can make you sick with COVID-19 or to get you the SARS-CoV-2 virus. Immunity after COVID-19 vaccination is a benefit. COVID-19 vaccination is a safer way to help build protection. That's a benefit. Once you are fully vaccinated, you can start doing more. That's another benefit. COVID-19 vaccines are effective. That's a benefit. COVID-19 vaccines are safe. Another benefit. Risks. If you look up the term reactogenicity, you will find some of these things I'm going to name. And you will understand that they're actually part of the immune response process that lets you know the vaccine is actually working. So we have common side effects: pain, redness, swelling, tiredness, headache, muscle pain, chills, fever, nausea. Rare anaphylaxis occurs in approximately 2 to 5 people per million. Rare, I spelled this wrong, it's myocard itis through follow-up, including medical record reviews. CDC and FDA have confirmed 518 reports. I think that has went up to maybe 1,000, but so has the millions of vaccines. So there's that. Uh, Rare blood clots, thrombosis, as of June 28, 2021, more than 12.3 million doses of J&J vaccine have been given in the United States. They only identified 38 confirmed cases. As far as death, it's extremely rare. It's 1% death rate. More like, was less than, actually, it's 0.0018% chance of death. I don't think there are any benefits to COVID. To my knowledge, if there is anybody that can correct me outside of obtaining natural immunity, which is risky and shouldn't be relied on, I don't know any. So feel free to add some. The risks to COVID-19 are whole hospitalization, intensive care, a ventilator to help breathe, or you may even die. Long COVID, diabetes, uh, lung damage, stroke, neurological damage, brain fog, and more. There's also the virus, which can cause heart damage and liver damage and other types of damage. When assessing risk, bear in mind there are 5 major types of risk: physical risk, for example, pain, bruising, and infection associated with venipuncture, muscle soreness, and pain as a consequence of exercising. Exercise test, heart attack induced by maximal exercise test, psychological risk, for example, stress associated with experiments and testing, feelings of guilt or discomfort because of sensitive survey topics, social risk, for example, invasion of privacy, loss of community standing, legal risk, for example, criminal prosecution or uh, revocation of parole, economic risks, for example, loss of employment, loss of potential monetary gain. Now, what you should do is insert a COVID-19 infection in there and see how it applies to the physical risks, psychological risks, and the rest of these risks, and weigh them and see if they are worth that. Because one of the important ones I would see would be the economic risk, because you're positive you have to isolate, which would mean you would have to miss work, and you miss work means you can't make any money. So that's a big problem for the majority of the people that live in America today. As you know, it's a pretty big economic gap in many social classes and constructs. So something to think about. Definition of minimal risk. Minimal risk means that the probability of magnitude of harm or discomfort anticipated in the research are not greater in and of themselves than those ordinarily encountered in daily life or during the performance of routine physical and psychological examinations. So keep in mind, is the vaccine minimal risk, or is the infection minimal risk? Something to keep in mind. Definition of benefit. A research benefit is considered to be something of health-related, psychosocial, or other value to an individual research subject, or something that will contribute to the acquisition of generalizable knowledge. Money or other compensation for participating in research is not considered to be a benefit. A great deal of research in social and behavioral sciences offer little potential for direct benefits to the subjects themselves. Rather, the benefits often encompass the importance of knowledge to be gained and or the contribution of research makes to science our society. So we're talking about a different dynamic, but it still can be applied as far as what the benefit is in dealing with the vaccine, in dealing with getting an infection. Uh, got Anthony Fonsi here talking to the Senate. This is after he uh, got on old Ron Paul, told him he was a liar, didn't know what he was talking about. He dropped some good information at the same time. So I'm going to try to get that on here. Let it load a little bit before I hit the play button. Here we go.
This to happen. But so I have a few questions just to, I hope, clear up some of the misinformation and misunderstandings. Dr. Fauci, the COVID-19 vaccine protects against the Delta variant. Is that correct?
It protects against the clinically apparent disease, and it protects extremely well against hospitalization and deaths.
Right, right. So if you're not vaccinated, given how contagious the Delta variant is, I mean, would it be fair to say you're very likely to get this variant, to get the COVID-19 variant, would you say?
Well, certainly when you look at the capability of this virus to transmit from people to people. I mean, obviously you have to be in an environment in which the virus is present. So if you are in for example, and I believe Dr. Walensky mentioned that in her remarks, if you are in a area, be it a state, a city, a county, or what have you, where you have a high level of infection in the community and a very low level of vaccinated people, the chances in that environment of getting infected are reasonably high.
Right, right. And how do you think about the risks, the side effect risks of the COVID-19 vaccine compared to the risks of not being vaccinated? Because this is, I think, what people are struggling with.
Right. It refers to the risk-benefit ratio of getting a vaccination. And every time this has been evaluated, not only with this vaccine, but with so many other vaccines, there is no intervention that is without sometime getting an adverse event. I mean, I don't think I can think of one that hasn't. So when you have that situation, you balance the rarity or the uncommonness of a particular adverse event with the advantage that you would get from protecting yourself against the actual disease against which you're vaccinated. And thus far, whenever this has come up about an adverse event, it's been evaluated, perhaps even a warning has been given, but it's always weighed on the part of saying that the benefit of the protection of the vaccine outweighs the risk of the adverse event.
Thank you. Dr. Walensky, I have spoken with a lot of public health experts in Minnesota who tell me that they are still challenged getting, especially younger adults, who are eligible to be vaccinated, getting them vaccinated. And part of it is the challenge, this perception that COVID is just not that big a deal for younger people who consider themselves healthy and I've got a strong immune system and so forth. So let me ask you this. Are there a larger number of younger people getting hospitalized today versus a year ago or 6 months ago?
We have seen hospitalizations go up for every age bracket recently as cases go up. Proportionally, because there are more cases now among younger people, we're seeing more of those people in the hospital. They still get hospitalized at a less frequent rate given unvaccinated than elderly patients. But in fact, because there are more of them now, we are seeing more of them in the hospital.
Okay, so another good piece of advice there about being aware of the risk, even if you see yourself as young and healthy.
Absolutely.
Thank you, Madam Chair.
Thank you. Senator Moran.
All right. Health belief model. The health belief model was developed in the early 1950s by social scientists at the U.S. Public Health Service in order to understand the failure of people to adopt disease prevention strategies or screening tests for early detection of disease, like, for example, preventative measures such as masking up and social distancing, washing your hands, and getting the vaccine. Those type of prevention strategies, or even going to go get a COVID test. Those type of screening tests for early detection of disease. The HBM suggests that a person's belief in a personal threat like COVID or of an illness or disease together with a person's belief in the effectiveness of the recommended health behavior like a vaccine or action will predict the likelihood of the person will adopt the behavior like getting vaccinated. The HBM derives from a psychological and behavioral theory with the foundation that the two components of health-related behavior are one, the desire to avoid illness and or perversely get well if already ill, and two, the belief that a specific health action will prevent or cure illness. Like getting vaccinated. Theory of planned behavior. The theory of planned behavior started as the theory of reasoned action in 1980 to predict an individual's intention to engage in a behavior at a specific time or place, like getting vaccinated. The theory was intended to explain all behaviors over which people have the ability to exert self-control. The key component to this model is behavioral intent. Behavioral intentions are influenced by attitude about the likelihood that a person, meaning that the behavior will have the expected outcome, which is why you hear a lot of people say, "Oh, if I still get, I still can get the virus, I still can get infected. So why does it matter?" That this is where that come from. And the subjective evaluation, see, of the risk and benefits of that outcome. The TPB is comprised of 6 constructs that collectively represent a person's actual control over the behavior, attitudes, behavioral intentions, subjective norms, perceived power, perceived behavior control. One thing that gets talked about a lot is efficacy and like the vaccines, but one thing that gets left out is self-efficacy. What is self-efficacy? Self-efficacy refers to the individual's belief in his or her capacity to execute behaviors necessary to produce specific performance attainments. Self-efficacy reflects confidence in the ability to exert self-control over one's motivation, behavior, and social environment. Think about that. What's your self-efficacy like? Conclusion. In conclusion, virulence represents the virus' ability to negatively impact the host, and viral fitness represents the virus' ability to replicate. Based on available data, there's an overwhelmingly objective benefit in vaccination versus not getting vaccinated against SARS-CoV-2. My goal was to hopefully educate those not aware of the information presented and assist them in making an informed, educated decision based on scientific evidence and not flawed personal beliefs or misinformation. Here are my references. Probably my video quality looks poor, so it's kind of hard to see. But if you really want these sources, get in contact with me. I can provide them if you can make them out. Do the video if you can make it better quality, and you can screenshot it and snag these. And go ahead. There's some more. Get those. Get these. These. That is it. My friends, I'm sharing my screen. Yes, so that's it. Try to make informed decisions, not forcing no beliefs, but also I am forcing facts on you. So take them how you want, and I'm out. KPRT up. My man Raw Squad up. Dagger Squad up. Mashi Warrior Clan up. Go buy Kofi's book, Beautiful Lessons of Moyo. We got Volume 4 on the way. My book is on the way. Give it a couple months. Still putting it together. We'll just gotta expand it. But yeah, man, look out for all KPRT products because we coming.